We're beginning Unit 2. The first section, 2.1, is on adding and subtracting polynomial expressions and functions. And we're going to begin Part A by adding and subtracting polynomial expressions. Some definitions here at the top. A monomial is a term, just a single term, that is the product of numbers and or variables which are raised to whole number powers. The coefficient of the term is the numerical multiplier of the monomial term, and the degree of the term is the sum of the exponents and all of the variables. So we've got a few monomials in this first box here. We're going to list their coefficient and their degree. So we're going to be using these two definitions. The coefficient is the numerical multiplier. So in 6x to the fifth, the coefficient is 6. And the degree, the sum of the exponents. If there's only one variable, it's the exponent. So the degree is 5. Okay. In the next example, x squared y to the fourth, the coefficient is the numeric multiplier. It's the invisible 1 in front of any variable. So the coefficient is 1, and the degree is 2 plus 4, or 6. In negative 8n, the coefficient is negative 8, and the degree is the invisible power 1. On n, there's one n there, so the degree is 1. And the last one, 5, the numeric component is the coefficient 5, and the degree, the number of variables that are present, must then be 0 since there are no variables. The degree of just a plain number, a constant, is going to be 0. Okay. A few more definitions. A polynomial is a sum or difference of monomial terms. The leading coefficient is the coefficient of the highest degree term, and the degree of the polynomial is the degree of the highest degree term. Okay, so if I'm trying to find the leading coefficient and the degree, I want to find the highest degree term. So the highest degree term in the first example, 2x cubed minus 5x, is 2x cubed. That means that the leading coefficient is the coefficient of that term, 2, and the degree is the degree of that term, so 3. Okay. In the next one, I'm looking for the leading coefficient. Leading coefficient isn't necessarily first, but if you were to write it in descending order, it would become first. So it's the term that has highest degree. So the leading coefficient, the coefficient of x squared, is negative 1, and the degree is 2. Okay. If there's more than one variable, to be able to find the leading term, I need to add up the exponents to find the term that has highest degree. So if I look at the first two, 1 plus 2 is 3, 3 plus 1 is 4, 2, and 0. It's going to be this term here, the 5x cubed y. So the leading coefficient is the coefficient 5, and the degree, 3 plus 1, is 4. Okay. The next one, the powers are x squared, x cubed, and no x. So again, the leading term is going to be the one with the highest power. Leading coefficient is 4x cubed, so 4, and the degree 3. And our last one, once again, two variables. You need to add up to find which term is the leading term. So my 4 plus 1 is 5, 5, and 6 plus 3 is 9. So this last term is going to be called the leading term. Okay. So the negative comes with it, so the coefficient is negative 8, and the degree, 6 plus 3, is 9. So we're going to flip our page, and on the back side, we're going to make a note that we would prefer to write polynomials in descending order. And descending order is going to have the leading term first in the polynomial, and then the polynomial exponents are going to decrease from left to right. That makes sense with the term leading. That term should be in first position. Okay, so a few definitions here. A polynomial of degree 1, if it only has highest power 1, is called linear. If it has highest degree 2, it's called quadratic. And highest degree 3 is cubic. So we're going to take each of these three examples here, rewrite them in descending order, write the degree, and then we'll classify them as cubic, quadratic, or something else. Cubic, quadratic, linear, or something else. Okay. So the first one, I want to just identify the leading term first. The leading term is the negative x squared. I would like the leading term to go first, so this should be negative x squared, then plus 3x. The degree of this polynomial is 2 because the highest power present in the expression is 2. Since the degree is 2, this is a quadratic expression. All right. In the next one, x to the 5th, x to the 3rd, x to the 4th, and no x. So the leading term is the -4, x to the 5th. Then descending order is going to have every single power decreasing by 1 if possible. So there is an x to the 4th term, so minus x to the 4th comes next. Then the plus 2x to the 3rd. There are no x squareds, so we jump to the plus 3x, then the minus 6. That would be in descending order. The powers of each term decrease as you read from left to right. The degree is the degree of the leading term, which is 5. And I'm going to have to just say none on this one. There is a word for a fifth degree. It's quintic, but it's none of the 3 that we're focusing on in this unit. It's not cubic, quadratic, or linear. The last one, look for my leading term. My leading term is going to be that 10x to the 3rd. So if I write this in descending order, the 10x to the 3rd will come first. Then the plus 8x squared. There isn't an x term, so I'm going to end with the plus 6. The degree is 3. That's the highest power present. Therefore, this is a cubic polynomial. A few more definitions. A polynomial with exactly one term is called a monomial. A polynomial with 2 terms is a binomial. And a polynomial with 3 terms is a trinomial. More than 3 terms, she's going to call it a polynomial because it has multiple terms. Okay? So we're just going to check a box here for monomial, binomial, trinomial, or not a polynomial. Okay? So the first one, I can measure terms as separated by additions and subtractions. This first one has 3 terms. That's going to make it a trinomial. The next one has 2 terms. It's going to make it a binomial. The next one only has 1 term. That makes it a monomial. The next one has a variable in the denominator. Variables in the denominator are going to cause this not to be a polynomial. I'm not allowed to have variables in the denominator, and I'm not allowed to have variables that have negative or fractional exponents in a polynomial. Okay? So I'll make a note over here on the side. No variables in the denominator or with fractional or negative exponents. That's not to say that functions can't have one of those things. It's just that makes them not polynomial functions. And back to our last one. Our last one has 1, 2, 3 terms. All of the powers are positive, so that's a trinomial. Okay. On to our next page. On this page, we're going to simplify polynomial expressions by adding or subtracting like terms. When I combine like terms, I simply add or subtract the coefficients. In order for the terms to be like, they have to have exactly the same variable component. That part remains the same. The only change is with the coefficient. So scanning through for like terms, we know that we want to write our answer in descending order. So we want to do the highest power terms first, then the next highest, and so on. So first we're going to add negative 4x cubed plus 2x cubed being the highest power terms. Negative 4 plus 2 is negative 2x cubed. Then you're going to look for the next highest. So you're going to go with your negative 7x squared minus your x squared. 2 negatives again, so it's going to add up to negative 8x squared. And last, you're going to have your 8x minus 1, and that is going to, sorry, those aren't like terms. Next, we're going to have these terms separately. So we're going to have our plus 8x, then our minus 1. Okay. So there were x cubes that were like, x squares that were like, and then 2 terms that had nothing to combine with because there were no additional x terms or constant terms. Okay. So this has been simplified. I couldn't add the x cubed to the x squared because they are not like. Let's look at part B. In part B, I have 2 different polynomial expressions that I want to add up. When I add them up, I add them by combining like terms, by adding like terms. So once again, we're going to look at our 4a squared plus our 2a squared, which gives us 6a squared. Then we're going to have our negative 9ab minus our 3ab, which is going to add up to negative 12ab. And last, we have our b squared minus our 6b squared. Those are like terms. It's like 1 minus 6 is going to add to negative 5b squared. In the last one, I have two polynomial expressions that are being subtracted. Now, as opposed to addition, if you're just adding things up, you can add without removing the parentheses because you're adding the a squareds, adding the ab's, adding the b squareds. Subtraction is going to be different because the subtraction sign needs to distribute, and it will change the sign of everything in the second parentheses. So you need to make sure that you distribute subtraction. Make ourselves a special note about this: distribute subtraction. Okay, so if I distribute my subtraction, the first set of terms will look like x squared plus 7x minus 1. Then I'll have minus 4x squared. Negative and a negative, we're going to make that plus 2x. Negative and a negative, we're going to make that plus 8. Then I'm going to group my like terms. I'm going to add my like terms together. So I'm going to have the x squared minus the 4x squared, giving me a negative 3x squared. That's 1 minus 4 is negative 3. Then we'll have our positive 7x plus 2x, giving us 9x. And last, our negative 1 plus 8 will give us a plus 7. So that expression has been simplified. If it's subtraction, distribute your subtraction first and then add up your like terms. Flipping to the back side of this page. Oh, part B.